Okay, hi everyone. Thank you all for joining. I know we're at, I think it is 4:15 right now. So if you didn't get the message before, this is a Jamboard. It has the link to our workshop materials. The link is on the bottom right. If you go to that page, you should be able to find this Jamboard and go ahead and drop a sticky note with your top future travel destination. That way I know you have access to all the materials, and I also get to learn a little bit about where everyone would like to go. And let me know if there are any technical difficulties, if you can't edit this board or you're not able to access the materials. It's like a great way for me to find out if there's any problems. And I'll give this like 2 minutes or something like that for people to come in.
Personally, really talking about ours, describe also.
होमवर्क करने के बाद ही जा सकता है।
Glad to see that some people are finding a board. Spain and Thailand, some like really cool places to go. Yeah. Is anyone having any technical difficulties finding any of the materials, getting to this board? Feel free to put in the chat as well.
Let me copy my.
Okay, cool. Let's maybe go ahead and get started. Again, if you've just entered into this workshop, then I have a board up here, a Jamboard. It has a link at the bottom right. It's terp/intro-ml. If you go to that, you can get to this Jamboard, drop your top future travel destination. Personally, I'm also curious since I feel like I should start traveling and exploring more. So maybe I'll get some good ideas from this board myself, and maybe the rest of you will as well. Which is also a way for me to make sure that you all have access to the materials. If anytime you feel like you have any technical difficulties, can't access something, just let me know, put in the chat, or feel free to unmute and say something about it as well. But I'm going to go ahead and jump into the presentation itself. So the presentation should also be linked in that folder. All right, let's go into slideshow. All sorts of Zoom controls everywhere on my screen, but all right. Um, okay, so today we'll be talking about getting started with machine learning. A little bit about myself. My name is Sagar. My pronouns are he, him. I am currently a software engineer at Stripe and live in Seattle. So unfortunately, I'm not in person. And I'm quite sad about this because I've really enjoyed presenting this workshop in person. I did my bachelor's and master's. I did a combined BSMS in computer science at UMD. I did research in computer vision and deep learning and specialized in machine learning. So feel free to ask me about any of that. Stripe, research, computer science at UMD, if you'd like to after this workshop as well. I'll be available on Slack as I'm also a mentor. My 5th year mentoring at Technica, and I'm super excited to be here. It's been one of my favorite parts of my college experience, and I'm happy that I get to do it again. And this is like one of like the 4 photos you'll find of me online probably, since I'm really bad at taking photos. But yeah, that's just a little bit about myself. Okay. So once again, the workshop materials are available at terp/intro-ml. You can also scan this QR code if you're trying to get to it from your phone and you'd like to just use that. I will pause here for a couple of seconds just to make sure that everyone has access to all the materials and can see the slideshow, the Jamboard, and also the different Colab notebooks we'll be using in this workshop. Um, Yeah, I'll give this like a couple seconds and then I'll continue unless someone objects in the chat or off of mute. And also just like a quick uh, look into what this folder contains. It should link to a Google Drive folder. Um, and I'm assuming you can see my screen here. Um, and it will have a couple of notebooks. Each of the notebooks that I'll go through has a template that we can walk through and also a solution that just has all of the code handy. So if you ever need to reference this, you can just look at the code cells in those notebooks there. I'll go over what Python notebooks are and also what Google Colab is as part of this presentation. You should also be able to see this presentation and also some links to previous presentations that I've given in the past. I have made this workshop as part of the series. And if you're interested in going further than this workshop, then you can reference those previous workshop materials. And every now and then I might just toss in a reference in the slides so you know what to look for as well. But okay, flipping back to the slides. So here's the rough breakdown of how I'm going to talk about getting started with machine learning. First, I'll talk about what machine learning is, the different definitions and types of machine learning. Then I'll talk about how it actually works, how these models are created and trained, and also what tools we can use. So I'll only go over a small subset of tools. There's actually a lot of tools that you can use for machine learning, but hopefully enough to get you started with your own hackathon project. Then I'll jump into talking about using Google Colab. We'll get a first look at what Google Colab is and creating your first notebook. And we'll also work with writing your first machine learning program. So actually writing a classifier that does some machine learning and getting yourself somewhat deep into the weeds with ML. And finally, I'll leave off with some closing remarks then. I'll also take questions. I'll pause for questions throughout this presentation as well. If you have any questions, feel free to ask. I've also left a space on the Jamboard. So going back to the Jamboard, if you go to the next screen, and let me admit people from the waiting room. Okay. You should be able to see that there is not that far, a place for questions. If you feel that this is a better format for asking questions, you can drop a sticky note here. I'll make sure to go back to this Jamboard and resolve any unresolved questions here. So how do I use Jamboard? Just make sure that you create a sticky note here, and then you can write your question. And workshop materials are, once again, at this terp/intro-ml. So you should be able to find all those materials there for new people joining. Maybe I'll put this in the chat too, if that's actually easier to click. And I will change the access on previous workshop material so that it actually can be accessed. Thank you for flagging that. Yeah. So let me change the permission on this right now so that we and so link to, yeah. Okay, so now everyone should have view permissions on some of the previous workshops and maybe like next steps if you're looking to kind of expand what we do in this workshop. Okay, let's go back. All right, so now going back to the presentation. So first, let's talk about what is machine learning. And there are a lot of definitions of machine learning. A lot of different entities have kind of defined what it means to be machine learning, and all of them are very different from each other. So I find it useful just to talk about a couple. So here's like two different sources, drastically different in how reputable they are. So from the MIT Technology Review, a definition of ML is using statistics to find patterns in massive amounts of data. And that's somewhat true. Like a lot of ML will deal with large amounts of data and finding patterns in it. Sometimes it's not massive, sometimes it's not just statistics, but that is partially what machine learning does. Wikipedia defines it as the study of computer algorithms that improve automatically through experience. And there's really a lot to unpack there as well. Like, what does it mean to improve automatically through experience? And what is experience for a computer program and model? So also a slightly vague definition, but also gives some insights into what ML actually does. My definition is study of teaching computers how to learn to make decisions. A lot of machine learning is, the way you might want to think about it is that in an algorithm, you kind of define the steps or like the heuristics that a model should look at and then make a decision based on that. But really you want to kind of create a model that finds those heuristics itself. So it's really just teaching these computers to learn to make those decisions and not just make the decisions them without that learning piece and learning aspect of it. Again, this is probably a little confusing and convoluted. Hopefully this will make more sense when I start talking about how machine learning actually works. There are also, oh yes, like a quick example that you might see is you have a data set that has some labeled photos of cats and some labeled photos of dogs. And this animation is really slow when I'm screen sharing it, but essentially it would go through these things called layers, and I'll talk about that more later. So this section with the blue rectangles can be your model, and hopefully it would output whether or not this image is a cat or a dog. So that's kind of the gist of maybe what machine learning is trying to accomplish. You have a data set, you're trying to perform some task on it, and trying to get some output out of it. And you might not have any idea about what's going on in that like box of rectangles, but hopefully it does it accurately enough and you're happy with the results that you see. There are also various different types of machine learning. These are three of the most common categories that you might see. So there's supervised learning, which is learning with labeled data. So the example here is called YOLO v3, and maybe at this time there's actually an updated YOLO version, but YOLO v3 essentially does object detection and classification. So the model is given images with cars and people, essentially like driving traffic scenes, and also a box around each of those objects in the scene and what label they are. So the model has all of this information, and then all it needs to do is, given a new image, figure out where the objects are in this image, figure out what types of objects are in this image. So supervised learning is learning with this label data. You give it not only the input images, but also those boxes and the labels as inputs to the model. In unsupervised learning, you're learning the structure of data. And so the example here is Google T-SNE. It's really small on the screen, but those different colored squares that are in that photo are actually different digits. So there's a very common toy data set. It's called MNIST, and it basically just has handwritten digits for numbers from 0 through 9. And in this case, Google T-SNE was able to cluster those images of handwritten digits. And you're able to see that there, that all the pink digits cluster together, all the red digits cluster together. So rather than giving information on this image has the number 7, or this image has the number 8, they basically just use the structure of that data to find out which groups are 7s, which groups are 8s. So unsupervised learning learns that structure of the data, and it has various different techniques that are different from supervised learning to make sure that they're able to do that. And finally, we have reinforcement learning, which is learning with rewards and punishments. So if you've ever taken a psychology class and you've learned reinforcement learning there, it's essentially the same concept. If you are taking psychology as a major, then maybe you'll not like that I said that, but essentially reinforcement learning is dealing with these rewards and punishments. Every time a model makes an action, it's given a reward and a punishment. So like kind of you could imagine like a digital cookie reward for staying on track, or if it veers off track in this AWS Deep Racer example, you give it a punishment, you like take away a cookie essentially. And so basically by getting these rewards and punishments, the model learns and improves. So these are 3 major types of machine learning. Are there any questions on this? I'll pause here before I go a little bit further. Questions on this or what machine learning is? And I'll also flip back to that Jamboard as well. I actually can't see the chat, so okay. Great. I see no questions, so I'll just continue. But if there are questions, feel free to interrupt or throw them in the chat. I'll make sure to check. Okay. Okay. So diving more into supervised learning, there are 2 main types of supervised learning. There's classification, which is making a decision about which classes certain data belongs to. So you might say in that dog or cat example, like the image belongs to a dog class or a cat class. You could expand it to all animals, and then you have like dog, cat, elephant, penguin, so on and so forth. In regression, you're making a decision about a continuous quantitative value. Basically, this might look like, say you're trying to model the stock market, you're trying to understand, trying to predict where the stock market will go. Then you no longer have these classes. You instead have like the actual maybe value of the stock or value of the option or so on and so forth. So that's called a regression problem. So when you have these continuous outputs, you want to look at regression. And when you have these classes, you want to look at classification. And the reason that I'm kind of diving into this and telling you all about this is that when you're working with your own ML task, a really easy thing to do to start is just like Google. Okay, I'm working with a classification problem that's supervised learning. Let me Google and see how people have done classification with supervised learning. So just knowing these terms can sometimes help you find the right resources and get you to the right place to get started. So I'm leaving these terms here. Feel free to go back to them later if they're a little bit confusing, but they can help you find the right resources a little bit faster as well. Okay. There are lots of other paradigms of machine learning. I actually won't go too far deep into this, but again, once you're trying to find things online, there are lots of different ways that you can think about machine learning. And I've left some examples here so that if you're working on something similar, you can kind of look into what this paradigm of machine learning is and what it means. This is also taken from one of the presentations in the more workshop materials folder. So if you're really interested about unsupervised learning specifically, that's where this slide is from. Okay. So now let's kind of dive into how does it work. But maybe before I do that, this is also a nice place for me to stop and make sure that no one has any questions. So again, I'll just skip the Jamboard and I'll make sure that no one is in the waiting room. Okay. I'll also just leave the link again in the chat so that if people are joining and weren't able to access the materials, they're able to access it now. Okay. I'll take silence as a good thing and continue moving on. Okay, so how does all of this actually work? So let's take like a deeper look into that model, that black box as it's sometimes called. So in a model, you have different layers. And these layers you'll have an input layer, an output layer, and hidden layers in between. So in this really simple example, we only have three. You have our input, our output, and just one hidden layer. Each of these nodes, as they're called in the hidden layer, have functions. So these are functions that you usually don't have to write yourself. Usually they are provided by whatever library you're using or whatever guide you're following, and they're commonly referred to as activation functions. You don't need to know too much about them other than the fact that they will basically take in these inputs from the previous layer and output something to the next layer. For each of these arrows that are going to the different nodes, you have weights attached to them. These weights basically just multiply whatever number is coming from the input, you multiply it times that weight, and it goes as an input to that function. So each of these arrows represents a weight. Now your input might look like an image. So if it's a cat image, it would be represented as the RGB pixels. So you'll get this matrix of pixels. They'll have the red, green, blue values. So if it was white, you'd have 255 on all three of them. And if it was black, you'd have 0 on all three of them. And that's the input that's given to your model. Yeah, I'll add sources for all the images and stuff as well. And your output will basically look like, is it a dog? Is it a cat? Sometimes you could even just represent it as one node. Like maybe if it's 1, it's a cat, and if it's 0, it's a dog. And initially, what will happen is that your model will do really poorly. It will probably have 50% probability of thinking that this image of a cat is a dog or a cat, since it really doesn't know any information. It hasn't been trained. Randomly, it's guessing, and 50% of the time it will be wrong, which makes a lot of sense. It's just a coin flip when you start out initially. As you start training this model, you'll see that these weights are the elements that end up changing. So you train the model, it sees more images of cats and dogs, and it will improve, it'll get better. So maybe now this model is 75% confident, and it did this by changing the weights in green, by increasing them, by decreasing the weights in red, and maybe not changing the weights in black at all. And we continue doing this through like multiple steps. And usually the initial jump is very high. So maybe initially we went from 50% to 75%. Then after that, it starts to plateau and we get to like 82%, 86, and then we start to see that the model levels off. So this is very common once you're actually training. You'll probably see huge improvements at the beginning and smaller improvements as you keep training. But basically, we're still in a good state. I mean, 85% confidence a cat, and we know it's a cat. So we know the model isn't doing too bad. This entire type of architecture is called fully connected. All this really means is that each node in the one layer connects to all the other nodes in the next layer. I'll kind of talk about this through the demo as well, but this is kind of like a basic gist of how machine learning works. You have these weights. The weights are the things that change. over time, you're hoping that the weights will change so that the probability that you're giving it some image is classified correctly. So in this case, a cat. And probably these improvements will decrease over time and get smaller and smaller until you get to some kind of convergence and it kind of levels off. Okay, so I know that was a lot of information. And are there any questions on any of this? Just how machine learning works, how maybe a model looks, and what's actually happening behind the scenes? And I'll go to the chat and I'll make sure there's no people in the waiting room as well. Okay, let's move on then. All right, there are also lots of other layers. I mean, Fully Connected is just one of them. I won't go too deep into this image. The reason that I've put this here is that if you're looking into an image recognition task, then these are the types of layers you'll end up using. When I step through a demo, then I'll also kind of talk about in a little bit more detail what these layers are doing. But I'll just leave this here as a graphic that you can reference later. So what tools can we actually use to do machine learning? And there are lots of them. Here's a couple ones that are really common. So NumPy is a great library for working with multi-dimensional arrays. What this really just means are, for example, that image was the height times the width times channels. In terms of dimensions, it was like a cube essentially that you pass into your model. So NumPy is a great library for working with for that type of data. If you had to do it with normal Python arrays, it'd be a little sad. SciPy is great for working with scientific and technical computing. It has a lot of different libraries, a lot of different methods for working with not necessarily deep learning, but other types of machine learning. Not mentioned here is also scikit-learn, which also does something similar, not necessarily deep learning, but other types of machine learning that I won't really cover in this talk. OpenCV is a great library for working with real-time computer vision. So if you're working on a hack that has a camera and you need to process those images really quickly, maybe you're trying to point that at something, then you can consider working with OpenCV as well for doing that real-time CV. There's also Pandas, which is a great library for data manipulation analysis. And if you have a tabular data set, which just means like you have a table and you're trying to perform some operation on it, then that might be a good one to look at as well. And let's see, TensorFlow is a great library for working with ML models. That's one that we're going to be using in this workshop. And finally, Matplotlib is a good library for plotting charts and graphs, display data. Let me see if I can. Okay. I might try to mute whoever's mic is on so that it's clear to hear, but it's a little harder to find. Maybe I will actually leave this to Maya, who is our wonderful organizer. Okay. Anyways, moving on. So how do you actually build an ML model for a hackathon? There are a couple of steps. So you would first obtain a data set and clean your data. This is the first step that you want to take, since whatever task you're trying to accomplish, you'll want to get the data first and then make sure that it's in a format that your model can consume. Next thing that you'll do is choose a model and architecture for that data. So to choose a model architecture, really what you want to do is look for previous examples, take into those terms that I talked about before, like maybe you're looking for a supervised model that does classification on data that's images or maybe tabular data. So kind of just put those into Google and try to find a good resource on what someone has done in the past. The next step after you find a model, you have your data, is to actually train that model on the data. We'll talk about what training looks like through some of this workshop, but essentially you might want to allocate a decent amount of time for this step as well. Training a model can take somewhere from seconds to hours, depending on how big of a model you're training. Training a very small model, it might just take a couple minutes. If you're training like a large language model, then it's going to take maybe a couple of hours. So make sure to keep that in mind as you're going through a hackathon and you're trying to factor in What is the best model to use? What do we actually want to show at the end of our experiments, and so on and so forth. Once your model is trained, you can evaluate it and determine how well it performs. It's a great statistic to have if you have a slideshow at the end of the hackathon and you're trying to show that, okay, we are 95% accurate on this data set. So our model is doing this good. It doesn't need to be a high number. Even low numbers, depending on how complex the task or model is, can be a good thing. So sometimes even 80% accuracy is amazing. So don't be like afraid of the statistic. You should just compute it, represent it, and show that you were able to evaluate your model as well. And finally, you have a deployment step where the model is actually deployed and users can interact with it. So these are like the rough steps of a hackathon, and in this workshop, we'll focus on these first 4 steps. So getting the data, cleaning it, getting a model, training that model, and evaluating it. And I did do a workshop in the past on deploying a model and actually hosting it completely for free and having it run predictions. So if you are interested in those materials, I've left them in the more workshop materials folder. Feel free to look at that, and you can also Slack me if you have any questions about that workshop. But if you are interested in deploying, then you can look at that, but we're only going to focus on the first 4 steps here. Okay, so again, I went over a lot. I'll pause right now. If there are any questions, I'll check the Jamboard and also check the waiting room. And again, feel free to just put it in the chat as well. And if I see nothing in like 10 seconds, then I'll start moving on. Okay, let me move on then and jump into Google Colab. So Google Colab is a free tool that allows you to use these things called interactive Python notebooks and work with machine learning. It's a great tool since you don't need a Google account. You can even use GPU resources, which is great. You can collaborate with other people, which is also amazing in a hackathon since you can share it with your teammates and work on things together. I will say that you can't edit things together, but since it is like in a Google folder, you don't have to do some version control and push and pull from GitHub to kind of work on the same notebook. But let's kind of jump right into it. So again, this Drive folder has all of the resources that we'll be using today. And we'll just use this first Colab notebook. I'm going to look on the template, but feel free to use this one if you don't want to follow along. So if you're new to Google Colab, it looks something like this. So you have these cells that are text cells and code cells. Text cells are in Markdown, and the code cells are in Python. So they'll look different here on the interface. It's a really great way by mixing text and code together, if you just want to demonstrate what your model is doing, you can kind of create like a report and like a summary, some descriptions of what each code cell is doing, and also what the model is doing here. If you are going to follow along on this template, just make sure that you hit File and save a copy in Drive. And this will create a copy for you in a new tab. And that way you can edit this copy and continue working with it. But the next thing that you'll want to know about Colab is that you have these files over here. So if you're working with some files, some data files, for example, you can just upload files here on the sidebar. There's other ways you can get access data as well. You can use Google Drive and link your Google Drive as well, which is quite useful if you don't want to upload, re-upload files every single time you create a notebook. Okay. The next thing that you have is a runtime. I think I'm already connected, but if you click this runtime button here, you can look into the different runtime types. There are like a CPU, a GPU, and a TPU available without having to buy any additional GPU materials. The GPU is what you're probably going to end up using for most of a machine learning project. You probably could use a TPU, but it's a lot harder to work with, so I wouldn't really recommend it. unless you want to actually write the extra code that goes into using the CPU. But using a CPU and a GPU are relatively simple, and using a GPU will make your life a lot easier. But in this notebook, I'm not actually going over the model itself. I'm just kind of explaining, so I'm just gonna leave it at CPU. Okay. Any questions so far about Google Colab and notebooks, the entire interface here? And again, I'll pause. That's the wrong way. Um, let's see. Yep, no questions here. I see questions in chat. Okay, thank you. I appreciate the note. All good. All right. All right. So let's just continue then. When you're writing, if you're new to Python, Python is relatively like English. It's a lot easier than Java, I would say. To say hello world, you can just do print hello world and just run this cell, and there you go. You see hello world. So in code cells, you'll see the code here and the output underneath it. It's also a very nice way to kind of save the output that you had when you're referencing a notebook later on. To print a range of numbers, you could just do for I in range 10, I'm going to use non-descriptive variable names. Let's just say print I, and then you'll see that now I have these 10 numbers here. So if you're using matplotlib, you can read images. I don't think you need this line anymore, actually. But so let me first go ahead and upload an image. So I have an image of dogs. I'm just going to drop over here. And I'll let that load and sync. And once again, I'm just going to throw in the chat the link to all the workshop materials. Okay. So I've uploaded this image here. I'm going to rename it so I don't have to type this entire thing. So to display an image, you can just do plot.imread. So you'll get this import line. It's very common to make pyplot as PLT. For whatever reason, that's a software convention when it comes to matplotlib. So we'll first just read this image. And then we'll show it. So it's plot.imshow and plot.show. You just show the entire thing. I don't really need the last line, but if I don't add it, then it'll add it'll show some other annotations. So this can be a little convenient. So now we can see that I've loaded this image of dogs. I've shown it here, and the image just displays really nicely in the notebook cell itself. It's a lot better than I think like a Python that you're running from your terminal, where it would probably not output this image very nicely and maybe in a different window. You can also do cool things like flip an image. So if I really wanted to, then I can take some Python syntactic sugar and do show this image, flip it across, I believe, the rows, and show it. And I think this should hopefully flip them upside down. And yeah, so the reason that I'm also showing this convention is because a lot of times when you're working with machine learning, sometimes you want to increase how much data you have. When it comes to images, the really simple thing to do is like flip them, rotate them, zoom in on things. There's lots of transformations you can apply. And it's really simple when you start using libraries like, in this case, NumPy and Matplotlib, where I can just do something like this and I flip the entire image. Okay, any questions so far on like everything that I've talked about? Then I'll jump into actually doing this with machine learning specifically. Okay, cool. Chat is empty, board is empty. I'll take that as a good sign. All right. So now let's jump into back into this drive folder. And there is a getting started with ML template interactive Python notebook. So if you haven't guessed already, the example that we're going to do is creating a binary classifier. So it looks at two classes and specifically cat and dog classification. So the entire presentation was hopefully leading up to this. It's not a huge surprise, but we're going to create a cat dog classifier on Colab. So let's swap back to it. And I'm just going to open this template notebook. As I mentioned before, I will make a copy of this notebook when it loads. So save a copy in Drive. Okay. Okay, great. So here, the first thing that we want to do is just connect this to a runtime, and specifically a GPU runtime. So again, you just click this runtime button, click change runtime type, and select that T4 GPU. It's not a great GPU, but it's not a terrible GPU either. So it'll work for any small projects. And so now we see that we're connected and shows that, we have like no use of RAM or disk. That's great. So the first thing that we'll do is download the dataset. This dataset is called AFHQ. It's, I think, a kind of cool dataset that was created by some paper that was working GANs. And it basically just has animal faces in high definition. So if you're thinking about doing something with animals, animal faces for a fun project, then this is a great data set to look at. It has images on all of these animals here. But I've already created this data set as a zip file. You can just run this gdown command and it will download the data set. Now, in the past, I've held this workshop and there have been problems with downloading since I one time held this workshop and my entire website crashed because there were so many people downloading this data set. So I leave alternative download links here too. If you are following along and this doesn't work for you, then you can use one of the alternative download links and feel free to use them after this workshop later as well if you'd like to reference or do something that we've done again. So once I've run this command, I should see that I have a dataset.zip file in my files here. And the next thing I'll do is I'll unzip this data set and I should see that those numbers reappear. Okay. So basically I have around 4,000 or 5,000, almost 5,000 images of dogs that are for training and 500 for testing. And I'll talk about what training and testing mean, but in this case, just know that we have successfully downloaded all of these images. If you do run these commands, you don't see these numbers, then it's an easy way to find out that maybe something went wrong with the download. Okay, so basically at this point, we have downloaded a data set that we found online. We've put it into our file system here, and we uncompressed it so that at least now they're all represented as images. If I was to expand this, I should see actually like test train, cat and dog, and I'm not going to click here because I'll open a 5,000 line list of all of the images there. Okay. Yeah, let me pause really quickly. And again, just cover my bases, make sure there are no questions. And if not, then I will continue. Okay. Great. So now let's actually talk about building the model. So we'll be using a library called TensorFlow. There are a couple of imports here, and I'll kind of talk about them as I actually use them. But for now, you can just run the cell, and we're going to like just scale all the images to 64 by 64. This is sometimes useful if you're working with really large images, since you can work with a smaller model if you just have smaller images. And at least for dog cat classification, the problem isn't complex enough that I would need something bigger than that. But maybe if you really want very high quality data to your model, you can choose bigger sizes for images. It's also very common to make images square. This can have some benefits when you're actually working with model architectures. So without really thinking about it too much, you can just resize it to a square and then continue working with whatever project you're working on. Okay. So the model that we're going to be using is called sequential in TensorFlow. And basically what it means is that each layer in this model will come after the other. When you're actually creating an object from a class in Python, it's super easy. You just put like parentheses any arguments. Since we have no arguments, we just don't put anything inside of these parentheses here. But yeah, so a sequential model, you have each layer comes after the other. You can make more complex models. Some people make models where you have layers that branch out from one layer, so you might have like some kind of random tree structure. But for a really simple model, sequential is probably the way to go. It's also probably the best way to go for a hackathon specifically. Okay, so let's go ahead and create this. And that ran successfully. So the next thing that we're going to do is add a convolutional layer. So the convolutional layer essentially takes a window. So if you had like an image of a cat, like, it goes across into cat, and you took a small window and applied it to the entire image, you just slide it across, and it would tell you some information, hopefully, on what's in that patch. And the reason this makes sense for images is because if you have a cat in like the bottom right corner or the bottom left corner, the top of the image, it should still classify the entire image as a cat. So by kind of taking these patches and applying it like across the image, you might be able to learn a lot of information from it. So an example of this could be like maybe one of those windows just classifies something as does it have whiskers or not, which would be a great indicator for a cat. And hopefully your convolutional window will basically just give you like a 1 or 0 output maybe on whether or not there are any whiskers in that patch. So to actually create this, we would just do conv2d and then give it some of our arguments here. I think Colab is very helpful. It even tells you what the method looks like. So we'll do 32 filters, a 3x3 kernel size, leave the strides as is. We'll give it an input shape. So I think it's like input image shape. Let me see. Yeah. And I might be wrong about the syntax, and I'll find out really quickly. But it's just going to be that 64 by 64 by 3. And then finally, we have this activation function that I think is really. So when it comes to these things like activation functions, you can kind of blindly use ReLU for most things. There is a lot of research and a lot of interesting work on which activation function you should use, but it's pretty common just to use ReLU. And these functions are those functions I talked about in the slide at the very beginning, where you have these functions on these nodes, you just take in these inputs and apply this function to those inputs to get an output. So yeah, for most of the time you can just use ReLU and things should just be fine. If you want to learn more, feel free to dive deeper into what activation functions are and what they do. Now I'm going to run this, and if it's like something like input image size, I think I'm going to have to change this. And hopefully that's the correct syntax. And if it's not, then luckily I have the notebook of the solution as well. So I'll just reference it really quickly. Yeah, unfortunately, I don't have all syntax of TensorFlow memorized yet, but that's what we have reference notebooks for. So let me just make sure what it is. Oh, it's in image size or input shape. Okay, there we go. And yeah. Okay. So, and I guess I did this wrong too. It's just activation. Okay. Okay, so that's run, and now we've kind of added one layer to our model. The next layer we're going to add is a max pooling layer. The reason we add this layer is that it basically reduces the size of the data that we're working with, and it also filters out some noise. So if we had the previous example where we found all these patches that had whiskers, maybe if you have 4 patches together, 3 of them have whiskers and 1 doesn't, you just want to represent that huge patch as whiskers. And again, this makes a lot of sense since if you find whiskers, you're pretty confident it's a cat. So this max pooling will just reduce all that noise, all the patches it found without whiskers, and focus on only the one that found with those whiskers. So to do that, we can just create a max pooling layer. So just max pooling 2D, and it's called pool size, which is the same as like a window size essentially. Again, feel free to dive deeper into what exactly these layers and those parameters are doing. I've left some comments and descriptions as well so that you can reference it later. So now we have our second layer. The third layer we're going to add is a flatten layer. This is mainly because at the end, we just want one value of whether it's a dog or a cat. we don't really need this height and width dimension. So at some point in our model, we should flatten it. So it's just a one-dimensional array. So to do this, it's really simple. You just add a layer that's called flatten. And then again, just make sure to create it into an object. And we'll add it here. And lastly, or almost lastly, we'll add this fully connected layer. So that's similar to the diagram that I showed near the beginning. And this layer will basically just apply some functions and hopefully create what's usually called an embedding of different information in the image. So hopefully one of these like nodes in this embedding will have some information on what is the probability that this image has whiskers in it, or like there's a patch with whiskers in it. And it could have lots of other information. So you'll get this, basically this output. Maybe you'll have something like, okay, one of them represents, does it have whiskers? Maybe another one has like, does it have paws? Does it have triangle shaped ears or something like that? Ideally, that's what you'd like to see. It's a lot harder to actually understand whether that's actually what happens. But the theory behind it is that that's kind of what you would get as an output. You'd get these outputs that represent the different features that would be in an image that can kind of tell you whether it's a cat or a dog. So then to do this, it's just dense, and then we do units equals 128 and activation equals prelude. And the choice of like 128 and 3x3 for these window sizes, or 2x2 for the pool sizes, just comes from like looking at different guides and just referencing them using their numbers. So that's a great place to start, since you probably just want to go off of something that works and then try to tune these according to make it better. So I did not make these numbers myself. I did not invent them myself. I looked at a guide, I followed it, I simplified it a little bit for this example, and that's why these numbers are here. Okay. Now, the last thing that we're going to do is we want to kind of create a prediction that's between 0 and 1 for whether it's a dog or a cat. So maybe like if it leans towards 0, it's a dog, and if it leans towards 1, it's a cat. And you kind of get like a 80% chance it's a cat, 25% chance it's a dog, or something like that. So to do that, we can just create another dense layer, this time with only one unit that represents that probability. And then we do an activation called sigmoid. And the reason we choose this is because it has an output between 0 and 1, which is pretty useful for representing something like probabilities. Okay, so now these are our last two layers, and we have our complete model. There is some other steps like compilation. I'm not going to talk about what these different things are. Again, feel free to look into this deeper, but essentially we're just making sure that our model is compiled, and it will do this binary classification problem. And dot summary will give you, here are the different layers that we've created, and also how many weights they have. And that's what this parameter is representing. So in this case, we have around 3 million weights that our model is training. Okay, that was a lot of information again. So I'm going to flip to the chat, flip to the Jamboard, make sure that I am answering any questions. And if not, I will continue. And okay, I will continue. Okay, once we are done with this, we can load our data. It's very common to load data in or train on batches. The reason you might do this is, imagine you're taking a class. In a class, when you get a lesson, you're probably going to learn a lot of things, not just like one thing. You're probably going to learn off a lot of examples. So each step it trains on, it'll take like some number of examples and think about them all in aggregate. So in this case, the batch size is 32. So it basically means we'll look at 32 images together, and then hopefully update our weights based on those 32 images. And then we'll keep looking at sets of 32 images to learn. The other thing that we do is we split into train and test data sets. You can kind of think about this as you don't want to just have the model memorize what it learned. So you can train it on a set of data, and you can test it on a different set of data, pretty similar to how you might learn something in class for your final exam won't be exactly what you learned or the exact problems you learned in class. So that's why you kind of create these train test data sets. You also sometimes have validation data sets, and I've written what it does here, but I won't dive too deep into it since we're not using it here. Okay, finally, we'll train the model. there's this fit function, and the description of what all the arguments that have been passed in here have been given, and that will actually train this model. And what you'll kind of see is that you can see that the accuracy is steadily increasing pretty rapidly at the beginning, but as it keeps training for more and more epochs, you will see that it plateaus, like I mentioned earlier. So at first we go from like 50 to 88%, which is great. Then we're going from like 88 to maybe 95%. So we're getting smaller and smaller improvements, but still improving. Like 96% is a pretty high accuracy for a model that we created, like, through this small demo and small workshop. The other thing that we can see here is the validation accuracy, which is released to our test data set. And it's usually lower than your trained data set, which makes sense since the model hasn't seen this data, so it's going to do a little bit worse, but it's still doing decently well. So we've only trained for 3 epochs, and we're able to see that this model has fully trained. And finally, once this finishes, I will just run this code block here to kind of show some examples, and you can see how it did. Okay, so now we can kind of see some examples that we pulled. And again, feel free to reference this code block if you're doing your own classification problem, you're trying to load in some images, then you can kind of see here that we have this output of a dog images, and we're about 99.6% confidence it's a dog. So it's pretty accurate and pretty confident. And we can see for some things we're not so confident, like this one at 69.3%, but it still was able to get the dog correct. Okay, so that's like a full overview of kind of how you can do machine learning with a small example, and also how you can look at some results at the very end. I hope this notebook was useful for that. I feel like there are probably no questions, so I'll just wrap up. I think we have about 5 minutes. Yeah. Okay. So some closing remarks. There's a lot more to machine learning than what I discussed. This is just a very small, simple example. And some really cool ones that I've put up here if you're interested in learning more about. The first one is called DALL-E. It basically generates images from dogs, and from images from text. And it's by OpenAI, which has been in the news a lot. Another one, the next one over here in the center top is a model called Palette. It fills in images by using generative AI, and it's pretty good at doing it. Like you could probably look at the image on the right and believe that that was the initial image. There's a model called AlphaGo that uses reinforcement learning to actually beat the best players at Go. One of my personal favorites is the one on the bottom left here, which is a hide and seek AI that was also done by OpenAI, where you had 2 hiders and 2 seekers, and they kind of learned new strategies at hide and seek by just like and playing with each other. And on the bottom right, there's this one called Nerf, which takes in a couple of images at different angles and then generates this continuous fluid motion GIF essentially from those images. All really cool models, all of different types of machine learning. And yeah, there's a lot to learn and a lot more to explore. I hope you all found this workshop to be at least good to get get a small introduction into it, and hopefully inspired you to learn more. I'm happy to take questions, but if not, also happy hacking everyone. If you have any questions during the hackathon, I'm a mentor. I'm available over Slack. I've left my LinkedIn and my email here as well if you want to reach out to me afterwards. And again, the workshop materials are at turp/introml. But that's all I had. I'll check the chat for questions. I'll be here if um okay. I saw the question on it's on GIFs. Yeah. I appreciate that. But yeah, I'll be here for any questions, and I'll also be available over Slack. But yeah, well, thank you all for joining.
Okay, I'm gonna have to close the room because I do have another workshop to go to. I'm sorry about that.
No, you're good. We're at the end, so that's perfect.
Yeah,
Yeah, thank you
but
so much, Maya, for all your help as
no,
well.
of course. Thank you so much. Your workshop was like extremely interesting. I've tried to do stuff like that in the past, but it just never ended up working out. So now I'll use your video to help like make myself a small mini project. Because I tried to do that over the summer, it just didn't work.
Yeah.
But I'll use
No, you
your
should
video.
definitely try it out. It's exciting, and I mean, I guess you're just starting as well, so you have so much more that you can be doing.
Yeah,
Uh,
yeah. I mean, I wanted to start out small, not take on too much, but yeah, definitely.
yeah, no, I mean, this is definitely a small thing, so I would hope that it's
Yeah,
not too bad. But I
yeah.
mean, also for you as well. Like, feel free to ask if you have any questions. I'm always available for that as well.
Thank you. I might actually reach out on LinkedIn to you because I took
Yeah,
a screenshot of your LinkedIn and everything. But thank you so much. I really appreciate it. And have a great rest of your day.
yeah, sounds good. You too. Good luck with the rest of workshops as well. Yep.
Thank you. I really,
Bye.
really appreciate it.
Yeah, of course.